briefly go over this worksheet. This is worksheet 10-7 if you're following along. Okay, so when you sum the forces, if you only have forces in the y direction, then you'll only sum the forces in the y direction. If you only have forces in the x direction, then you'll only sum them in the x direction. Then if you have forces in both directions, it sort of depends on which direction is the most interesting or what you're looking to find, but oftentimes you end up summing the forces or finding the net force in both the x and the y. This worksheet, though, has cued you as to which direction you should sum the forces. So you sum the forces in a direction. It's always the up forces minus the down forces. So the force of tension is positive because it's going upward, and the force of gravity is downward on the box, so it's going to be subtracted. The force of gravity, the net force in the y direction, because this box is in equilibrium, will be 0. Again, all of the up forces, so the force of tension minus the force of gravity minus the force on the box by the man. There are 2 downward forces and only 1 upward force. When we look at the book, this is exactly like the problem above, the normal force instead of the force of tension minus the force of gravity. The net force on the book is exactly like the net force on the box, except you have a normal force going up instead of that tension force. When an object is moving, you need to decide whether that object is moving at a constant speed, whether it's in dynamic equilibrium, or whether it is accelerating. If it's in dynamic equilibrium, then this sum of the forces is going to be equal to 0. So this bowling ball is moving across the floor at a constant speed. There is no friction, so there's nothing that's going to be pushing it to the side. So there are no x forces, just the normal force minus the force of gravity. On the other hand, when we look at this basketball, we only have 1 force on it. The forces are not balanced. This basketball is going to accelerate. And so the sum of the forces in the y direction, that up and down, is not going to be equal to 0. Tomorrow, next class period, we'll learn about Newton's second law and what that net force is going to be equal to. There are no forces in the x direction on number 6 or number 7. And number 6, this basketball is only going to be accelerating downward, so there will only be a net force downward. The sum of the forces in the x direction will be equal to 0. These problems have both forces in the x and in the y, but it doesn't matter if the table doesn't move in this case, or in this case, number 10, when the table is moving at a constant speed. Number 7 and 10 will be exactly the same. We have the same free body diagram where the force of friction equals the applied force, and we have the same sum of the forces, the same net force given. And then again, for number 8, we have 3 forces in the y direction. The force on the table by the lamp is also a downward force, noting that the force normal, that upward support force, will be bigger, or will be equal to the force of the lamp plus the force of gravity.